Tonight, we gently explore the life of Michael Faraday, a man whose quiet curiosity and patient observation changed the way the world understood electricity and magnetism. Faraday was born in 1791 in Newington Butts, a small and quiet suburb of London. His family was poor but diligent, and his father worked as a blacksmith. From an early age, Michael learned the value of careful, steady work. The rhythms of his childhood were simple and calm. The ringing of the hammer on the anvil, the warmth of the forge, and the scent of metal and smoke were familiar companions as he grew. In that quiet environment, he developed an appreciation for careful attention and repetition, habits that would later define his scientific work. As a child, Faraday loved to read and explore ideas, though books were scarce in his modest home. He often borrowed what he could and devoured each page slowly, savoring every lesson. At the age of 14, he began an apprenticeship with a local bookbinder and bookseller, a small workshop filled with the smell of leather and paper and the soft warmth of sunlight filtering through dusty windows. There, young Michael spent hours carefully binding books, mending torn pages, and observing the detailed craftsmanship around him. The quiet work allowed him to think, and during these hours, he began to explore the world of science through the pages of the books he bound and repaired. Chemistry, electricity, magnetism, and the work of earlier scientists became a source of endless fascination. Evenings in the workshop were calm and still, punctuated only by the occasional footsteps of passers-by outside and the soft rustle of pages. Michael began performing small experiments in the limited space he had at home. Candle flames flickered gently as he tested the properties of gases. Magnets, wires, and small bottles of chemicals became his tools for exploring invisible forces. He carefully recorded observations in his notebooks, sketching diagrams of what he saw, noting tiny changes that occurred over time. Patience and repetition became part of his daily rhythm. When an experiment failed, he did not despair. He adjusted, tried again, and observed more closely the following day. At 20 years old, Faraday attended a series of public lectures by the famous chemist Humphrey Davy at the Royal Institution in London. The lecture halls were quiet yet filled with the subtle energy of attentive listeners. Candles and lamps cast soft pools of light across wooden benches, and a low murmur of anticipation filled the room. Faraday, notebook in hand, recorded every detail carefully, fully absorbed in the experiments demonstrated on stage. Inspired, he wrote to Davy, enclosing his detailed notes and expressing a desire to work with him. Davy, impressed by the meticulousness and clarity of Faraday's observations, offered him a position as an assistant. Moving into the Royal Institution, Faraday entered a world both bustling and deeply contemplative. Laboratories were filled with the faint smell of heated chemicals and the soft hum of experiments underway. Glass flasks and jars, wires, and coils filled the rooms. Bunsen burners flickered gently, heating solutions, while microscopes and balances waited quietly on wooden benches. Faraday's days settled into a rhythm of careful observation, note-taking, and assisting Davy with ongoing experiments. He learned to mix solutions slowly and accurately, to observe subtle changes, and to appreciate the quiet patience required for discovery. In these early years, Faraday began his own independent experiments. He studied the properties of gases, how substances reacted under different conditions, and slowly turned his attention to electricity and magnetism. He observed that moving magnets could influence electrical currents in wires and noted the patterns in these invisible forces. He experimented with coils of wire, carefully measuring the currents and drawing diagrams that recorded his observations. The work required long hours of calm attention, sometimes late into the night. In the quiet of the laboratory, only the occasional scratch of pen on paper, the soft bubbling of a chemical reaction, or the faint hiss of steam disturbed the stillness. Life at the Royal Institution allowed Faraday to explore, test, and think deeply. Outside, London was noisy and crowded, filled with the clatter of horses, carriages, and street vendors. Inside the laboratory, however, time seemed to slow. Faraday moved deliberately, carefully observing every experiment. Even small variations in the strength of a magnet or the shape of a wire could reveal new insights. He developed the habit of repeating each test many times, noting differences and patterns with patient persistence. Faraday's early work on chemical reactions revealed small but significant insights. He discovered how certain molecules interacted, how solutions behaved when heated, and how crystalline structures formed. Each careful observation added to a growing understanding of the physical world. Yet even as he studied chemistry, his thoughts often wandered to the invisible forces around him. Electricity and magnetism, mysterious and unseen, seemed to him like threads connecting the world, and he longed to understand their patterns. By the end of these early years, Faraday's life had settled into a gentle but intense rhythm. Days passed quietly, filled with the soft sounds of experimentation, the gentle movement of tools, and the patient observation of reactions, both chemical and electrical. Faraday had begun a journey that would slowly illuminate forces invisible to the eye, but powerful in shaping the modern world. His life was a testament to calm attention, persistent observation, and the quiet, steady pursuit of understanding. As Michael Faraday grew older and settled into life at the Royal Institution, his days became measured by the quiet rhythm of observation and experimentation. Each morning he arrived in the laboratory before most of the city had fully awakened. The streets of London were still damp with morning mist, the distant sound of horse hooves faintly echoing through narrow lanes, and the occasional bell of a church marking the hour. Inside the laboratory, glass flasks, metal stands, and coils of wire awaited him, quietly reflecting the soft morning light that filtered through the tall windows. He would move slowly through the space, carefully checking each piece of apparatus, ensuring that balances were level, flasks clean, and burners properly arranged. Faraday's work often began with simple experiments, yet they required extraordinary patience. He would set up a coil of wire, carefully connecting it to a small battery or magnet, and watch as an invisible current passed through, sometimes producing only the faintest deflection on a compass needle. He recorded each subtle movement in his notebook, not rushing, noting even the smallest variation in angle or speed. Sometimes hours passed before any notable change occurred. The quiet ticking of a clock, the soft scratch of pen on paper, and the faint hiss of chemical reactions formed a gentle background to his steady, focused attention. In these moments, Faraday's mind wandered freely within the world of electricity and magnetism. He began to see patterns where others saw only mystery. If a magnet moved near a wire, could it induce a flow of electricity? Could currents create magnetic forces in return? He tested each possibility methodically, adjusting the distance of the magnet, the thickness of the wire, and the strength of the current. Each test was repeated many times, sometimes on consecutive days, until he was certain of the result. His assistants learned to move quietly around him, understanding that interruptions could disturb the delicate focus required for such work. Evenings were often spent in contemplation and note-taking. By then the city outside was cloaked in shadows, gas lamps casting warm, flickering light along the cobblestones. Faraday would sit at a long wooden table, reviewing the day's observations, sketching diagrams, and carefully reflecting on what the results meant. He frequently revisited experiments that had seemed inconclusive, adjusting variables ever so slightly and patiently observing the outcomes. The slow pace of his work, punctuated by these quiet moments of reflection, allowed him to make connections that might have been missed in hurried investigation. Faraday also continued his studies in chemistry, not just as a subject of curiosity, but as a foundation for understanding electricity. He explored the behavior of liquids, gases, and compounds, observing the effects of heat and pressure on different substances. His meticulous attention revealed the hidden patterns in reactions that appeared random to others. Small changes in temperature or concentration could produce entirely different results, and Faraday learned to respect the subtle influences of the environment around his experiments. Over time, he began to focus more on the relationship between electricity and magnetism. It was a slow, deliberate process, one that required him to construct and reconstruct apparatus, coil wires in precise arrangements, and observe how moving magnets produced electric currents. The experiments were quiet but deeply absorbing, with only the gentle hum of equipment, the occasional clink of glass, and the soft scratch of pen on paper filling the air. Sometimes he would sit back in a quiet chair, observing the movement of a needle or the glow of a small lamp, considering what the result might mean for the unseen forces at work. Faraday's work attracted increasing attention from other scientists. He began giving lectures at the Royal Institution, but even these public appearances were conducted with calm and deliberation. He spoke slowly, clearly, and with a quiet passion, guiding his audience through the steps of each experiment. Spectators watched as he demonstrated the delicate interactions of electricity and magnetism, the gentle motion of wires, and the faint glow of currents moving invisibly through circuits. The demonstrations were simple yet profound, revealing the beauty and order hidden in forces that could not be seen directly. Outside the laboratory, Faraday's life remained simple. He lived modestly, often walking through quiet streets or along the banks of the River Thames, reflecting on the day's experiments. The city, with its distant sounds of life, was a backdrop to his calm, focused thoughts. Even in these moments of solitude, he considered the next step. How could the discoveries in the laboratory be applied to real-world problems? How could the invisible forces he had begun to understand be harnessed for practical use? One of the early realizations that slowly formed during this period was the principle of electromagnetic induction. Faraday observed that moving a magnet through a coil of wire could create an electric current. The idea was subtle and invisible, yet he confirmed it repeatedly, carefully measuring the current and sketching detailed diagrams to record the results. Each repetition strengthened his understanding, and gradually a pattern emerged that suggested electricity and magnetism were closely linked in a way that could be predicted and measured. Through years of patient experimentation, Faraday also discovered that the amount of electricity generated depended on the speed of the magnet's movement, the number of turns in the coil, and the strength of the magnetic field. These insights were not immediate. They developed slowly over months and years of quiet observation, repeated tests, and careful reflection. The work required attention not only to the phenomena themselves, but to the environment. Drafts in the laboratory, the temperature of the room, even the placement of glassware could influence results. In the evenings, after long hours in the laboratory, Faraday often returned to small private studies where he read, sketched, and considered the implications of his findings. The quiet ticking of a clock, the muted light of a lamp, and the occasional murmur of a distant street formed a calming environment for deep thought. Here he connected observations from different experiments, imagining how the forces of electricity and magnetism could be applied to create new technologies. Faraday's steady, deliberate approach allowed him to see connections invisible to others. He realized that magnetic fields could not only produce electricity, but also guide and control it. He began experimenting with coils, iron cores, and conductors, laying the groundwork for inventions that would eventually power cities and machines. Each discovery emerged slowly, built on careful observation, patient repetition, and a deep respect for the subtlety of nature. Through this long period of meticulous work, Faraday developed a deep understanding of the natural world. His discoveries were not sudden flashes of genius, but the result of years of quiet labor. The calm, rhythmic days spent observing, testing, and reflecting formed the foundation for principles that would later become essential to modern science and technology. In small London laboratories, surrounded by glass, metal, and the soft sounds of careful work, Michael Faraday's quiet curiosity was slowly revealing the invisible forces that would illuminate the modern world. As Michael Faraday's understanding of electricity and magnetism deepened, he began exploring how these forces could be connected in new and surprising ways. By this stage, the Royal Institution had become a place of quiet innovation, filled with shelves of glassware, coils of wire, chemical solutions, and delicate measuring instruments. Assistants moved quietly through the rooms, careful not to disturb ongoing experiments. Faraday himself often spent hours observing a single coil of wire, a small magnet, or a lamp glowing faintly as electricity passed through it. He repeated tests over and over, sometimes for weeks, seeking patterns that would reveal the hidden order behind these invisible forces. His meticulous nature allowed him to notice subtle effects others might have overlooked. A small change in the angle of a wire, the distance of a magnet, or the temperature of a conducting metal could influence the result, and he recorded each detail carefully in his notebooks. One of Faraday's most profound discoveries emerged during these quiet hours: electromagnetic induction. He observed that when a magnet moved through a coil of wire, it produced an electric current. The idea was invisible, almost magical, yet consistent. He conducted experiment after experiment, varying the speed, strength, and arrangement, carefully noting the results. It was a slow, patient process, but it revealed a principle that would form the foundation for electrical generators and transformers. Faraday realized that electricity and magnetism were not separate phenomena, but part of a connected, dynamic system. The implications were enormous, though at the time, he only saw them as pieces of a carefully woven puzzle, waiting to be understood fully. Faraday's work was not limited to theory alone. He designed intricate apparatuses to test his ideas, often building them from simple materials with his own hands. Wires were coiled around iron cores. Magnets were suspended from delicate stands, and chemical batteries provided a steady flow of current. Every device was treated with care, each adjustment made slowly and deliberately. His assistants became attuned to his quiet routines, knowing that even the slightest noise or disturbance could affect the precision of an experiment. In this calm environment, discoveries unfolded gradually, almost imperceptibly, until a moment of clarity emerged, revealing the elegant simplicity behind complex forces. Faraday also turned his attention to the practical applications of his discoveries. He understood that the principles he was uncovering could one day illuminate homes, power machines, and transform daily life. Yet he approached these possibilities without haste. Each experiment was guided by careful observation rather than ambition, and each result was tested multiple times to ensure accuracy. He realized that progress in science depended not on flashy demonstrations, but on patient, repeatable work that revealed the underlying truth of nature. During this period, Faraday also began a series of public lectures at the Royal Institution, carefully designed to share knowledge in an accessible and inspiring way. The lecture halls were quiet, filled with attentive listeners. Gas lamps cast warm light over rows of benches, and the soft murmur of the audience settled into silence as Faraday demonstrated his experiments. He spoke slowly, guiding the audience through each step of a demonstration, allowing them to witness the gentle motion of a magnetic needle or the faint glow of a wire conducting electricity. His calm, deliberate style drew people in, showing them that science was not only a collection of facts, but also a process of careful observation, patient inquiry, and thoughtful reflection. Outside the laboratory, Faraday's life remained simple. He often walked through the streets of London, observing the world with the same attentiveness he applied to his experiments. He watched the motion of carriages, the sway of trees in the wind, the flow of water in the river, seeing in everyday phenomena the same laws that govern electricity and magnetism. These quiet reflections complemented his laboratory work, providing a steady rhythm of observation, thought, and insight. Faraday's experiments also began exploring the interaction of light and magnetism, a subtle effect that would later influence the study of optics and electromagnetic waves. He discovered that light could be rotated by a magnetic field, a finding that suggested a deep connection between magnetism, electricity, and the very nature of light itself. This observation was made slowly, through hours of patient testing, careful alignment of equipment, and repeated measurements. Each small result contributed to a larger understanding, a web of knowledge being built gradually, quietly and deliberately. Even as Faraday made groundbreaking discoveries, he remained humble and reflective. Fame did not change the rhythm of his days. He continued arriving early in the laboratory, conducting experiments, observing, recording, and reflecting. His focus was never on recognition, but on understanding. And in this quiet, methodical pursuit, he laid the groundwork for technologies that would later power the modern world. Electric motors, generators, and the very principles that would enable the transmission of electricity across cities and nations. Through these long, slow, and deliberate years, Michael Faraday demonstrated that the most profound discoveries often emerge from patient attention to small details. The gentle hum of equipment, the faint flicker of light in a coil of wire, the careful alignment of a magnet, and the meticulous notes in a quiet laboratory formed the foundation for a life of exploration and understanding. It was a life that revealed, over time, the invisible forces that shape our world, showing that curiosity, patience, and thoughtful observation can illuminate mysteries far beyond what the eye can see. As Michael Faraday's career progressed, the quiet and patient work he had carried out for decades began to reveal profound applications that would eventually shape the modern world. His discoveries in electromagnetism, electricity, and magnetism were no longer confined to the small, still rooms of the Royal Institution. The principles he uncovered, the ability of moving magnets to generate electric current, the interactions between electricity and magnetic fields, and the delicate relationships between light and magnetism, formed the foundation of technologies that would illuminate homes, power machines, and transform industries across the globe. Faraday also continued to conduct his famous series of public lectures, now known as the Christmas Lectures. These were gentle, carefully orchestrated presentations designed to make science accessible to young minds and the wider public. In the softly lit lecture halls, he demonstrated experiments with glowing wires, suspended magnets, and revolving coils, guiding the audience through invisible forces that shaped the world. His calm voice, deliberate pacing, and careful explanations allowed listeners to follow even the most subtle phenomena. Children, students, and adults alike were drawn into the quiet wonder of electricity, magnetism, and chemical reactions, seeing for the first time that the natural world followed consistent and observable laws. These lectures were not performances of spectacle alone. They were exercises in patient observation, thoughtful demonstration, and the gentle unveiling of hidden truths. In the laboratory, Faraday continued to explore new possibilities. He built early versions of what would later be called the electric motor, demonstrating that a wire carrying a current could rotate around a magnet. He experimented with magnetic fields, induction, and the properties of conductors and insulators, always with careful attention and slow, deliberate testing. Days passed quietly, punctuated only by the soft scratch of pen on paper, the gentle hiss of heated solutions, and the faint hum of electricity flowing through coils of wire. Each observation, each repeated test, contributed to a steadily growing understanding of forces that, though invisible, had the power to move the world. Even outside the laboratory, Faraday's attention to detail and calm observation continued. He would walk through London's streets, reflecting on the patterns of movement, the flow of water, or the motion of the city around him. Every sight, every small change in light or shadow, every subtle vibration became part of the larger framework of understanding that guided his experiments. These quiet moments of reflection allowed him to connect what he observed in everyday life to the abstract principles he explored in the laboratory, creating a seamless understanding of nature, both seen and unseen. Faraday's discoveries were remarkable not only for their scientific significance, but also for their simplicity and elegance. The relationships between electricity and magnetism, the induction of current by movement, and the rotation of light in magnetic fields were all phenomena that could be observed with patience, careful attention, and repeated experimentation. He demonstrated that even the most complex and seemingly invisible forces could be measured, understood, and applied. His work inspired a generation of scientists, laying the foundation for the development of electric generators, transformers, and the transmission of electrical power over long distances, which would one day illuminate cities and connect nations. Throughout his life, Faraday remained humble and deeply reflective. He did not seek fame or wealth, and he lived modestly, dedicating himself to the pursuit of knowledge for its own sake. Even as letters and visitors poured in from around the world, seeking guidance or insight, he maintained a calm focus on observation, testing, and reflection. For Faraday, the laboratory was a place of quiet discovery, a sanctuary where patient attention could reveal the hidden structures of the universe. His contributions extended beyond practical inventions. Faraday's work fundamentally changed the way scientists thought about nature. By demonstrating the connections between electricity and magnetism, he revealed that the physical world was governed by consistent, observable laws, that invisible forces could be understood through careful study, and that knowledge acquired through patient observation could be applied to improve the human experience. He also emphasized the importance of simplicity, clarity, and thoroughness in experimentation, principles that continue to guide scientific practice today. As he grew older, Faraday's health began to decline, yet his curiosity remained undiminished. He continued to read, reflect, and guide younger scientists in the laboratory. The gentle rhythm of his days, walking, observing, experimenting, recording, and reflecting, continued to define his life until the very end. By the time of his death in 1867, at the age of 76, he had transformed the understanding of electricity and magnetism, leaving a legacy that would shape science, technology, and everyday life for generations to come. Michael Faraday's life demonstrates the power of quiet curiosity, careful observation, and patient persistence. In the still hours of the laboratory, in the gentle light of early mornings, and in the slow, deliberate motion of experiments repeated again and again, he revealed the invisible forces that govern the world. His discoveries remind us that profound understanding often emerges not from sudden inspiration, but from steady, persistent attention, and that the smallest details, observed carefully and patiently, can illuminate the greatest mysteries. Faraday's legacy is a world transformed by electricity, light, and magnetism, a testament to the quiet determination of one man who spent his life observing, reflecting, and understanding the invisible threads that connect all things.